Hey friends, hope you're doing well. Today I'd like to show you a great Python library which helps you to optimize your neural networks. So, have you ever wondered, how can I get the best neural network? What are the best settings, the best hyperparameters? If so, this video is for you. So, the library I want to talk about is Optuna. Optuna helps us to optimize and find out the best parameters for our neural network. So the way it works is, you can see here I use Colab, but you can use, of course, any kind of editor you want, or Jupyter Notebook. If you have installed it locally, it's up to you. You just need to install Optuna first, and then you can use either TensorFlow or pytorch. In my case, I'm using pytorch here, and I'm using the MNIST dataset just as an example in here. But of course, this can be applied to any machine learning library and also to any kind of dataset you have. So I first import my libraries here, and then I import Optuna and the trial from Optuna. So then I download the MNIST dataset, in this case here from Deutsche Vision datasets, and said I have here download true, and it's training data, and for the transformation, all I do is I convert it to tensor. You can also normalize it and do other kinds of things like cropping and so on, data augmentation if that's required, but in this case I'm using just to tensor as transformation. So then I put the dataset in a loader, because in PyTorch what we want is we want to feed our data in batches. The same is true for TensorFlow, but in this case we just use a train loader here, and this allows us then to put our dataset into a train loader to get some batches. And we specify the batch size here, which in this case is 64, because most often you use any kind of multiple of 8 to do that, or multiple of 4. I'm not quite sure, but more or less the same. So for the training loader, we also want to shuffle the data. For the test loader, we don't do that. So now in Optuna, we need to define a function. And this function here is the objective function. You can call it whatever you want, but objective is just some standard word you use for that. And you feed in trials. Now for the trial allows you to suggest, ranges for various hyperparameters. So in this case, for instance, specify for the layers in my neural network, I want to have an integer value, that's why it's called suggest int, between 1 and 5. And the same is true for the hidden size, so the amount of nodes I have, I want anything between 50 and 200. So these are the ranges, and Optuna should then find out and test values within this range and figure out, is it then at the end, is it a better configuration or not. The number of classes are 10, because that's the MNIST dataset, and the input size will be here 784. Of course, if you use convolutions, then in your model, then be aware that is 2828, right, for the size. So then for the learning rate, we also suggest a value, or the trial suggests a value, but in this case, it's a float value. Between these are the boundaries here, and I call it learning rate. The name you put in here, it's up to you. It's just an example. So then we define our model. In this case, that's S1, and I'm using a simple model with linear layers and ReLU as an activation function in here. Then the model also goes through the forward function that is here and returns an output. And then we create the model, we instantiate it, and send it to device, in this case to CUDA. And then we specify criterion, it's a cross entropy loss, and also the optimizer. In this case, we use Atom, but you can also use SGD if you want. So then we do a typical loop, in this case for the epochs, and within the epochs for each of the batch in the train loader. So batch is a tuple, so we use images and labels, and we send them also to CUDA, so on the graphic card, so on the GPU, because then the training is faster. Then we put the data into the model, we get an output, and then we calculate the loss in here. So, and then we calculate the gradients, and then we optimize that. And finally, that's important, we return the loss. So for Optuna, within the objective function, we need to return something. Either accuracy as a metric, for instance, or in this case, the loss. So, and the final thing, which happens here, by the way, I'm not sure if you sent that on my screen, but that happens here. So the final thing which needs to happen now are these two things. At first, we create our study in here and specify the direction. The direction here is minimize, because we return the loss and we want to minimize the loss. And then the final thing is that we optimize the study. So we say the objective function is a function we want to optimize, and then the number of trials are 10, which means we have 10 iterations in total. And each iteration has then, went through all the epochs with a specific, suggestion of the various hyperparameters we have. And you can see that down there. Now we run through the various trials, and then it calculates the loss. It spits out the loss out here, and at the end it has a final loss for the third epoch, and then it specifies what kind of parameters did it use. In this case, 4 layers, 138 nodes, and this is the learning rate to calculate a loss of 117. And the same is true then for the next 9. So in total we have 10. The next 9 iterations, and you can see that here, and you get basically the amount of nodes, the configuration here, and then the loss. And this tells you at the end, after the 10 trials, you see exactly, okay, what was the lowest loss you were able to achieve, and what are the hyperparameters. And you have this, then you can just optimize or change your model and use it use the specific hyperparameters which created the lowest amount of loss. And that's it. So hopefully that was helpful. If you liked it, then please give this video a like. Also share it with your friends if it's helpful, and please subscribe to the channel. Thanks a lot, take care, and see you in the next video.